All right, this time I thought I'd do something a little different rather than write things up, which takes me forever since I'm not particularly good at it. This is, I'm going to explain a little bit how I'm going to try to make this car go back and forth. I've owned this particular train car for a while. I'm not really into trains, but I like that it was a pump motion. Mr. and Mrs. Claus pump the handle to make the train, well, looks like they're making the train go back and forth. The problem is that this particular train only goes one direction, and I'm working on a display for outside, and I wanted to have this in there, but I wanted to go all the way one way, stop for a while, and all the way back. And so I'm going to record a little something here to try to explain what I'm doing. Maybe it'll be helpful to somebody else. What is different about this is that we're going to have to do some work to the train track as well as the train. So I wanted to give a little background, and pull this out here so this gives you a better idea what it is. This is O-Scale. There's a few different kinds of train tracks, in case you're wondering. O-Scale has the 3 rails. HO is half of O in size. That's the one you see most places. There's N, which is these super small ones. G, or I think stands for garden. They're ones that you would maybe put out in your yard. Kind of look like the ones you put under your tree a lot of years. So I'm going to be working with O. I like it because it's bigger, and the size makes a little more sense for a Christmas village, which is what this is going to be going around. I have a piece of O here, and the way O works is the outer 2 rails here are connected, and the middle rail is isolated from them. And if you look close, you can see on this metal bracket here that connects everything, the middle one has a little piece of paper, or it depends on the train track, but all it is to insulate it so that even though the bracket is holding all 3 together, electrically the outer 2 are connected and the middle one is separated from it. So usually you can put the ground on the outside, put your power on the inside, but it doesn't really matter. You can do what you want, and in this case I'm going to be having it go back and forth, so it will be switching. So the train here, if you look at the instructions, what they point out is that the car can operate on either AC or DC, and they mention a couple different kinds of O track that it can operate on. Don't worry about that. But the fact that it can do AC or DC means that we're going to have to do a little work to fix it. So that it can go both directions. It's only going to go one direction right now, and they even point that out in there. So I'm going to walk through the steps to do that. Before I do, I did want to point out, so these outer wheels here, they connect to the outer track, and then the middle one connects to the inner track, and that's how it makes its connection. So the electricity runs through and causes the motor to spin, which propels it forward, and then they also have this little gear system here that causes the handle to go up and down. So next we need to take this apart, and there's just 2 screws here. They're pretty quick to take apart. We'll go ahead and do that now. Okay, I got those 2 screws out, and that's it. That's all it's holding it together. It's a little plastic cover. I'm not going to take it completely apart because I don't want to potentially break any of the inexpensive gears that are in there. But what you can see is there's a motor. The motor drives this little warm gear in here. Not sure if you can see it with the lighting. And that turns the wheels, but also then turns this larger gear, which causes the Mr. and Mrs. to pump the car. Pretty straightforward, very simple. This car doesn't do anything else. There's no lights or anything like that. But what's important to see is right here, this is what they call a bridge rectifier, and that's what we're going to have to fix. So I wanted to give a little bit of background on a bridge rectifier. So in electricity we have things called diodes, and a diode, if you look at it on a schematic, is going to look something like this. You have your anode, you have your cathode, and it's a positive and negative end. Okay, so what a diode does is it allows current to operate in one direction only. It'll block the current going the other direction. And it's a pretty nice feature. Obviously, you can break it and current will go both ways, but the short answer is that it does this. So if you ever see a diode, it usually will have a look kind of like this with a little bar on it. It's usually a black diode with a silver bar, and that's how it'll go in the circuit. Okay, so same thing, schematic symbol and then the actual symbol. And the reason that you use these is that you can make sure that you don't hook something up backwards and break something in your circuit, or maybe you want, in this case, to use a bridge rectifier. And what happens is, if you've got something like this is AC voltage. AC is what your house operates on, and also a lot of train systems operate on. They're not using the same voltage as your house, so don't plug that in. But it goes positive, negative, positive, negative. Okay, that's not going to help. Your motor's going to be confused. It's going to want to go forward, want to go backward, want to go forward very quickly, many times a second. Now, if we were to put a diode in series with this, what would happen is, since we're only allowing electricity to go through one direction, you'd end up with the positive, nothing, positive, nothing. So now you only have positive electricity coming through. That's great. If you have DC voltage, it's always positive. And so if you had it going through a diode, it would be the same thing. It would always come out. There's never change. There is a voltage drop for a diode. That's okay. It's usually something small like 0.7. You need to be aware of it, but for this simple explanation, you don't need to know. And so if you had a diagram of it, you would have, say, your AC voltage source here, and you had your diode. The current's going to go through like this and complete your circuit. And when it's doing that, you're going to end up with this sort of system. In the DC, you'll have it more like this, and it'll be the same thing. If you were to switch and try to put the negative through, you'd get nothing. It would end up at 0 volts. So what I wanted to explain a little bit is that one part that you could see, and it's called a bridge rectifier. So let me draw a quick schematic diagram here. So it's a series of 4 diodes in a particular orientation. They kind of form this sort of diamond look, and this gets used all over for various things. Christmas lights use these. A lot of things that want to be inexpensive but convert AC to DC. So if you were to think of this circuit, this would be your AC input. Now I'm not going to draw a plus or a minus because AC swings both ways, like I said. And so they're going to come into these points A and B. And then if we call these points C and D, what happens is, and this little hump here means I'm sort of jumping over it. I'm not making a connection there. What happens is this will convert it to a DC voltage. This would be your negative, and this would be your positive. All right. And it's real simple how it does that, and it's very smart. If we go back to our sine wave, that's AC. I drew before that the diode only allows current to go one way. So you would get this beginning of hump, 0, get a hump, 0. But what's going to happen now is that the When the positive voltage comes in, it goes through this route here. You have the 2 voltage drops, but they're very small, and so you see the positive coming out. When it's going negative, the negative comes in and you go backwards through. So the negative comes through and the positive here. So you end up with something that does this. It's always positive. Now the train doesn't do this, but what a lot of things will is they'll add a capacitor, and the capacitors, they store a charge and then can slowly release the charge. And the way that works when you put it into the system here is you can actually, while this voltage is positive, it'll slowly release the charge. So you end up with this sort of look where it's almost constant. And that's how you can get sort of a DC. That's not a good thing for if you have something that needs very exact voltage, because you end up with this not very clean line. But for most things, and like this DC motor, that'd be good enough. So what we need to do is take out that, because if, as we've pointed out, if you have a DC, pretend this was DC voltage and we hook it up backwards because we wanted the train to run the other way, this bridge rectifier is going to make the voltage come out on the same wire again, so the train's just going to go. Now that particular bridge rectifier that is in here, it's this unit here, and you can even see in the schematics that they show the bridge rectifier. These little squiggly lines here are the AC voltage, plus or minus, that's your DC voltage. So they show you here in this schematic for the part that that's how the breakdown works. So we're going to pull that out, and then hopefully we don't break anything, and this will allow the DC motor to be able to operate forward or backwards just by changing the polarity. Okay, so I've pulled out that bridge rectifier. You can actually see it right here. Kind of hard to tell, but you can see the 4 wires, and so 2 of them were the AC and 2 of them were the DC out. All I did was pull the 2 wires that were going into the bridge rectifier, put them straight onto the motor. Okay, actually screwed it all back together because I wanted everything to be nice and tight, and so we're going to put it on the track here. Remember, the outer 2 connect to these outer 2 rails. This middle piece here is what connects to the middle rail. So when I put it on and I turn on the voltage, we should see it go one direction. I'm going to stop it, I'm going to switch the polarity of the voltage, and we should see it go the other direction then, if it works. Okay, that's pretty good. Switch the polarity of the DC. All right, that's exactly what we wanted it to do. The thing to keep in mind now is that I cannot run AC on that because I've taken out that bridge rectifier. So this is now only a DC hand pump car. And that's fine by me, because the next step is going to be how to automatically change the voltage on these so I don't have to sit there and do it with my hands while the prop is running. And so that's going to be the next step of this test. But that was good. That was what I needed it to do.
2,000 years later.
Okay, I finally got all the pieces in to finish up the back and forth motion. And even though the kit was designed for an HO, it should work on anything that's using DC. So it should work with this O-Scale. This is the little board I bought. Could have made something, but sometimes it's easier to just spend the few dollars, get it, and not have to do everything from scratch. So the way this works is you set it up so that it has an on time and an off time, which is a little confusing the way they word that, but basically it switches the polarity of the voltage going in for various times. And so in this case, for now, for this example, I'm just going to do 4 seconds and 4 seconds. So it'll allow the train to go 4 seconds one direction and then 4 seconds the other. And depending on how long the run is, it'll end up sort of sleeping at the end. And what that means is that when it gets to the end of the track, it's going to stop, and however much time is left in that, in this case 4 seconds, it'll sit there. Then when the polarity switches, it'll go the other way. And the way he is doing that, the people who designed this, it's pretty slick. But like I was saying earlier, the outer two rails are connected and the inner rail is isolated. So what we're going to end up doing is we pull off the inner pin here, and I bought some of these, which are replacement pins, but they're nylon. And you can see they have a little collar on them there. And so what happens is if you put this in, you can put it in place of the pin. And when you connect to the rest of the track, the outer two will make a connection. So those pins, metal pins, allow there to be a connection. This middle one here, the train can go across this, but there's not going to be any continuity between the two. So you do this on the two ends of this track. And when the train car gets to here, it won't work anymore. It'll just sit there until the polarity changes, and then it'll go the other direction and do the same thing at the far end. And how they do that is by using some diodes, like I mentioned earlier. And this kit came with some. These are pretty small. I think they're 1N 4001s. Just because this is going to be for an O-scale, not HO, I decided to beef it up a little bit, and I had some of these RL207s, which are pretty much the same, but they will source a little more current. And so what you end up having to do is you have to solder across from one side of the track to the other, and you do that on both of them. And this is what allows, since we know the diodes only allow current to go one direction, this will allow it to stop when it gets to the end, and then when the polarity switches on this little board here, when the timer goes off, it'll then go the other way. So I'm going to finish putting this little piece of track together, and I'm going to solder these on, and we'll see if it works. This isn't how I plan to do it when the prop gets out, but I wanted to be able to finish filming this and explain it. But I have that little nylon nail between the two here, so this connection is not being made. And then I have my diode here. The important thing is to make sure the diode is facing the same direction at the far end, which I do have. And so the only connection between this middle rail and this middle rail is this diode here, and that's what's going to allow the train to get down, stop, because there's no hot connection here, but when the voltage changes, it'll allow current to go through that diode and will go the other direction. So I'm going to zoom out a little. Okay, I'm going to turn it on, and we should see if it works. If you listen closely in the background, you hear some clicking. That's the relay that's switching the polarity of the voltage. The relay is mechanical, so you'll actually hear the switch go. All right, well, that seems to work. So that's what I'll end up doing. It'll be a much longer track when it goes into the prop than these 4 pieces here, but I needed to test it and to vet it, and I wanted to show a little video to explain it. And so that's what I have for now. Next time should be a video showing this actually in the prop. Should be 10 to 12 feet long, and it'll hopefully be pretty neat. All right, thanks.